Okay, so we're going to take a look at rational equations. That would be section 6.4. So solving rational equations. Rational equations can be used to solve several different kinds of problems, such as work-related problems, where two people or machines work together at different rates to complete a task, which we will be doing later in this lesson. Just to define rational equation, it is an equation containing at least one rational expression. So some examples are x is equal to x minus 3 over x plus 1. So here's your rational expression, x minus 3 over x plus 1. And x over 4 minus 7 over x equals 3. So your rational expressions are x over 4 and 7 over x. So working with a rational equation is similar to working with rational expressions. A significant difference occurs because in an equation, what you do to one side, you must also do to the other. So I'm just going to remind you of the difference between solving a rational equation and simplifying a rational expression by using fractions, okay? So let's say you want to simplify x over 6 plus 1 over 2. Okay, you need a common denominator, so your LCD is 6. So that would give you x over 6 plus, and then a half becomes 3 over 6. So when you go to simplify this, you're going to have x plus 3 over 6. Okay? Now, what if you had an equation that you had to solve? So for example, let's say it's x over 6 plus 1 over 2 equals 24. So now you have an equation, okay, and you know that because you have an equal sign. So your common denominator is still 6. And actually we're going to make this 24 so our numbers don't, 4, so our numbers don't get too big. And what you're going to do with your 6 now is you're going to multiply every part of your equation by 6. So remember, what you do to one side of the equation, you must do to the other. So I'm going to take my 6 and I'm going to times it by x over 6. And then I'm going to take my 6 and times it by 1 over 2. And then I'm going to take the 6 and times it by the 4. So I've multiplied everything in my equation by 6. Okay, so 6 times x over 6 is x. 6 times a half is 3. And 6 times 6 times 4 is 24. And then when we go to solve this, you find that x is equal to 21. Okay? So hopefully this will help to clarify the difference between what it means to simplify rational expressions and what it means to solve rational expressions, okay? So what you do with your denominator is different in both instances, okay? So for this one here, you're just going to multiply this by 6 over 6, okay? And when you're asked to solve, you have to multiply every term by 6, okay? So hopefully that will help you for the rest of the lesson. Hi, so we're going to be solving rational equations. To just review the steps with you, we factor each denominator, we identify our non-permissible values, we multiply both sides of the equation by a lowest common denominator, and we solve by isolating the variable on one side of the equation. Now, just to remind you, you can get two kinds of equations, at least at this point. One will be linear, and the other can be quadratic. Okay? And then, of course, with solving equations, you should always check your answers. So let's just look at our example here to review all the steps. We're going to solve x over 4 minus 7 over x equals 3. And we're going to use the lowest common denominator to express each denominator as 1. And if you remember from class, I said that that would eliminate the denominator. Okay, and the lowest common denominator for this equation is 4x. and we are going to proceed by multiplying both sides of the equation by the LCD. Okay, so you can see we have a 4x on the left and a 4x on the right. And also what you can see is that we've identified our non-permissible value as x can't be equal to 0. Okay, so we're going to distribute the 4x over the binomial on the left. So we get 4x times x over 4 minus 4x times 7 over x is equal to, and then just the 4x times 3. Okay, so when we go 4x times x over 4, we can reduce the 4's, and we're left with x times x, which is x squared. On the middle portion, we can reduce the x's, and 4 times 7 is 28, and 4x times 3 is 12x. Because this is a quadratic, okay, and we know that because we have an exponent of 2 on the x, we are going to set everything equal to 0. Okay, so that means moving the 12x over to the left, and it becomes negative. All right, so then we're going to solve by factoring. Okay, and we find that x equals 14 and x equals negative 2. Now, the purpose of your non-permissible value is to let you know whether your solutions are possible, okay? And because the only value that x can't be is 0, then we know that 14 and negative 2 are possible answers, okay? Or that they are answers. So it is important to realize that non-permissible values are identified from the original equation and that these values cannot be solutions to the final equation. Okay, so let's try our first example. We are going to solve a rational equation, and we are going to determine the non-permissible values. Okay, so remember, your first step is to factor your denominators. So the one on the left, we've got z squared minus 4 in the denominator. That's a difference of squares, so we're going to factor it as z minus 2 times z plus 2 plus 10 over. We have a common factor of 6 in the denominators here, so we're going to take that out. We've left with z plus 2, and that's equal to 1 over z minus 2. All right, and as you can see, you can't factor that one. Okay, so we can do our non-permissible values right now. All right, we've got z minus 2, which can't be 0, so z can't be 2. We have z plus 2, which can't be 0, so z can't be negative 2. And our LCD, okay, is z minus 2 times z plus 2, and don't forget the 6, okay, because that's part of one of our denominators. All right, so now what we're going to do is we're going to take each part of this equation and we're going to times it by our LCD. Okay, so we're going to go 6 times z minus 2 times z plus 2 times 2 over z minus 2 times z plus 2 plus our LCD again, so 6 times z minus 2 times z plus 2 times 10 over 6 times z plus 2, and that's equal to our LCD again, so 6 times z minus 2 times z plus 2 times 1 over z minus 2. Okay, and so next we're going to reduce what we can. So over on the left here we can reduce the z plus 2 and the z minus 2. And then in the middle we can reduce the z plus 2. And on the far right we can reduce the z minus 2. Okay, so what are we left with? Well, 6 times 2 is 12, plus we've got, oh, look what I forgot to do. I forgot to reduce the 6's. Okay, so now we're going to have 10 times z minus 2, which will give you 10z minus 20, and that's equal to 6 times z plus 2 times 1, which will give us 6z plus 12. All right, notice we have a first degree equation, which means it is linear. Okay, so we don't have to worry about factoring or anything. So we're just going to bring all of our z's over to the left and our constants over to the right. And so we're going to move the 6z over. 10z minus 6z is 4z. On the left, we have 12 minus 20, which is negative 8, and we're going to bring the negative 8 over to the right and add it to the 12. So we're going to have a negative 8 turn to a positive 8 once it's on the other side. So we get 12 plus 8 is 20, divide by 4, and we get that z is equal to 5, where z cannot be equal to plus and minus 2. Okay, so notice that our non-permissibles are that z just can't be a positive 2 or negative 2, so 5 is reasonable. Okay, that is a solution, but we're going to check anyway. So let's check over here. Okay, and just a reminder, you want to always check into the original equation, and you want to show that the left side is equal to the right side. Okay, so we're going to go 2 over z squared, so 5 squared, minus 4 plus 10 over 6 times 5 plus 12, which is equal to 1 over 5 minus 2. So now we've got 2 over 25 minus 4, which is 2 over 21, plus 10 over 6 times 5 plus 12, which is 10 over 42, and that's equal to 1 over 5 minus 2, which is 3. Okay, and when we simplify what's on the left, we get 1/3, and that's equal to 1/3, so the left side equals the right side, and so 5 is our answer. Okay, next one. All right, so now we're going to take a look at an example where we have an extraneous root. Okay, so remember that an extraneous root is a solution or a root that you get at the very end on the last step that doesn't work in the original equation. Okay, so we're going to go through first and start by factoring our denominators. And we don't have too many of those to worry about, just the one on the right. Okay, so k squared minus 4 is a difference of squares, so we're going to get x plus 2 times x minus 2. Okay, our non-permissible values, we've got k plus 2, can't be 0, so k can't be negative 2, and we have k, oh, that should be k, shouldn't it? Okay, and k minus 2 shouldn't be 0 or can't be 0, so k cannot be equal to 2. All right, and our LCD is going to be k plus 2 times k minus 2. All right, so we're going to multiply every part of our equation by our LCD. All right, so this part, the middle part, and the right part. So we go k plus 2 times k minus 2 times 4k minus 1 over k plus 2 minus k plus 2 times k minus 2 times k plus 1 over k minus 2 equals, and then k plus 2 times k minus 2 times k squared minus 4k plus 24 over k plus 2 times k minus 2. Okay, so let's do some reducing. On the far left, k plus 2's can reduce. In the middle, the k minus 2 can reduce. And on the far right, k plus 2 and k minus 2 can be reduced. Okay, so we now have on the left k minus 2 times 4k minus 1 minus, and we're going to put this in a square bracket because we want to minus the whole thing, and we have k plus 2 times k plus 1, and that's equal to k squared minus 4k plus 24. Okay, so we're going to FOIL on the left. We're going to get 4k squared minus 9k plus 2 minus, in brackets, k squared plus 3k plus 2 is equal to k squared minus 4k plus 24. Okay, now note, we have to distribute the negative because we want to minus everything inside the bracket. So we're going to have 4k squared minus 9k plus 2 minus k squared minus 3k minus 2 equals k squared minus 4k plus 24. Okay, so because we have k squares, we know we have a quadratic. And so we want to make everything equal to 0. And when we do that, we will get 2k squared minus 8k minus 24 equals 0. We have a GCF of 2. So we'll factor that out. So we get k squared minus 4k minus 12. And then we can factor our trinomial. The factors of 12 that will give us 4 are 6 and 2. Make the 6 negative, the 2 positive. And we'll go over here. And so we get that k is equal to 6 and k is equal to negative 2. All right, now let's go back to our non-permissible values. Okay, we know that k can't be negative 2 and it can't be 2. And take a look, one of our solutions is that k is negative 2, so we have to reject this one. Okay, and so our answer is k is equal to 6. Okay, so the negative 2 is your extraneous root. Okay, so it's the root that you get that isn't a possible answer, okay, because of your non-permissible values that you have up here. Okay, so I'm going to end this now, and then I'll do a part 2 for the word problems. So we're on part 2 now of solving rational equations. We're going to take a look at 2 word problems. The first one is a rate problem, and the second one is a work problem. 2 friends share a paper route. Sheena can deliver the papers in 40 minutes, and Jeff can cover the same route in 50 minutes. The question is, how long to the nearest minute does the paper route take if they work together? Okay, so it's helpful to have a table to organize your information. It's not necessary, but it's helpful. If we take a look at the question, how long, how long to the nearest minute does the paper route take if they work together? Then we know that our let statement is going to reflect that question. So let, and we'll use t for time, so we're going to let t be the time it takes for them to do the route together. Okay, so in filling the chart, the first column will have the names of our characters, so Sheena and Jeff, and we also want to include together. Okay, if you take a look at the problem, our time is in minutes, so when we fill in our second column here, we have to recall that our time is in minutes, so Sheena can do this paper route in 40 minutes, and Jeff can do it in 50, and we don't know what their time is together. Okay, so we want to know what the fraction of work is done in 1 minute. So if Sheena takes 40 minutes to deliver the papers, then the fraction of her work that she will get done in 1 minute is going to be 1 over 40. And if Jeff can do it in 50 minutes, then the fraction of the work that he can get done in 1 minute is 1 over 50. And for t, following this pattern, you know the next one has to be 1 over t. Okay, so the next thing we want to ask ourselves is what fraction of the work is done in t minutes? Okay, that's the time that they do it together. All right, well, if 1 minute is 1 over 40, then to find out what the fraction of time it is for t minutes, we have to multiply. So we're going to go 1 over 40 times t, which will give us t over 40. And then for Jeff, we're going to go 1 over 50 times t, which is t over 50. And for the time together, 1 over t times t, which is t over t, which just gives you 1. Okay, and just recall from class, this value will always be 1. Okay, so what is our equation for this? Well, we know that if we take the part of the time that Sheena can do the work in t minutes and add that to the part of the time that Jeff can do work in t minutes, that should give us a whole complete job. Okay, in this case, doing the paper route. So we're going to add those. We're going to go t over 40 plus t over 50 is equal to 1. So as you can see, we have a rational equation. Our LCD is 200. Okay, and so we're going to multiply every part of our equation by 200. So we're going to go 200 times t over 40 plus 200 times t over 50 is equal to 200 times 1. Okay, so let's do some reducing. 40 goes into 200 5 times, 50 goes into 200 4 times, and there's no reducing on the right. Okay, so we get 5t plus 4t is equal to 200. And that gives us 9t equals 200. And then t is equal to 200 over 9, which gives us about, let me put this, about 22 minutes. Okay, now you can check your work, but don't check with the fraction, check with the fraction. Okay, so we go back to our original equation, plug in 200 over 9 for t. Okay, remember that when you divide fractions, you multiply by the reciprocal. Okay, and 40 goes into 200 5 times, so that gives you 5 over 9 plus 50 into 200 is 4 times, so 4 over 9. And 5 over 9 plus 4 over 9 is 9 over 9, so 1 equals 1, and we can show that left side equals right side. Okay, and so it takes them about 22 minutes to complete the paper route together. Okay, so we're done this one. Let's move on to our second word problem. Okay, so the Northern Manitoba, I'm sure I should have put trappers in here, festival held in the past originated in 1916. A championship dog race has always been a significant part of the festivities. in the early days, the race was non-stop from the pass to Flin Flon and back. In one particular race, the total distance was 140 miles. Conditions were excellent on the way to Flin Flon. However, bad weather caused the winner's average speed to decrease by 6 miles per hour on the return trip. The total time for the trip was 8.5 hours. What was the winning dog team's average speed on the way to Flin Flon? Okay, so let's just remind ourselves that our distance formula is distance is equal to rate times time, or if you're in physics, it would be velocity times time. Or time is equal to distance over rate. And if you remember your triangle from science, you can use that too. That the distance is equal to, we're going to use v for velocity, is equal to velocity times time. Okay. Okay, so we want to know what was the winning dog team's average speed on the way to Flin Flon. So we're going to use that to determine our let statement. So we're going to let x represent the average speed. Okay, which in this case is miles per hour from the pass to Flin Flon. Okay, now once again, it's helpful to have a chart to help organize your information. Okay, there's two parts to this trip. There's the trip to Flin Flon. Okay, and there is the part of the trip which is the return. Okay, so you're going to use the information from the word problem to fill in the chart. You know that the for this race that we're looking at, that the total distance was 140 miles, so that means you're going to go 70 one way and 70 the other. Now, their velocities, we don't know what that is, okay? We want to know, though, what the average speed was from the pass to Flin Flon, so we're going to call that x. We'll put that here. We know the return trip was slower because the weather was bad. So the speed was decreased by 6 miles per hour, so we're going to write x minus 6. And we don't know what the time is except to say that the total time is 8.5 hours, so that's total time. And we're going to write that as 17 over 2. Okay. All right, but if you take a look on our chart here, if we want to figure out what time is, because that goes in our last column, time is the distance over the velocity. So we're going to write for the trip to Flin Flon as the time being 70 over x, and the return trip from Flin Flon as being 70 over x minus 6. Okay, so how can we determine our equation? Well, we know that if we were to add the time to Flin Flon to the return time to the pass, we would get total time. Okay, so that means we would go 70 over x plus 70 over x minus 6 is equal to 17 over 2. All right, so we need an LCD. Our LCD is going to be 2 times x minus 6, or if you like, 2x times x minus 6. And our non-permissible values are that x can't be 0 and 6. Okay, so let's multiply the different parts of our equation, the left, the middle, and the right, by our LCD, which is 2x times x minus 6. And so we times 70 over x by that. And then 2x times x minus 6 times 70 over x minus 6 is equal to 2x times x minus 6 times 17 over 2, and it's getting a little crowded here, so let me move this over. Non-permissible values, x can't be 0 and 6. Okay, so let's reduce what we can. Okay, we can reduce an x over here. We can reduce an x minus 6 in the middle, and on the right we can reduce a 2. Okay, so what are we left with? We are left with 2 times x times 70 plus 2x times 70, which is equal to, let's say 17x times x minus 6. And so we get 140x plus, oh, I forgot something, didn't I? We want to go 2 times x minus 6 times 70. Okay, so that gives us 140x minus 840 plus 140x is equal to 17x squared minus 102x. All right, notice you have a quadratic, so you want to make everything equal to 0. So we're going to go 0 equals, we're going to bring everything over to the right because I want my x squared term to be positive. And I get 17x squared minus 382x plus 840. All right, now this is factorable, but like I said in class, if you didn't feel that you could factor this, you can always use the quadratic formula, right? Which is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, but I know it's factorable, so I'm going to factor. And I get 17x minus 42 and x minus 20. Okay, so when I solve for x, the first factor that I get, or sorry, the first solution that I get is 42 over 17, which works out to 2.47. And then x equals 20. Okay, so here are two possible answers, 2.47 and x equals 20. Now, neither one of them conflicts with our non-permissible values, so let's see how they work in our chart. Now, we know that x is the average speed in miles per hour from the pass to Flin Flon. So on our chart, that means it's right here. So let's say x equals 20. Then 20 minus 6 will give us 14. Okay, so that seems to work. Let's try 2.47. If x is 2.47, then we're going to get 2.47 minus 6, which gives us negative 3.53. Now, we can't have a negative rate, can we? So we have to reject this, okay, 2.47, and so our answer is 20. Okay, and once again, you can check that out, okay? Let's just plug it in over to here and see what we get. Okay, we know that our total time should be 8.5 hours. So if I put in 70 over 20, okay, I get 3.5. And if I get 70 over, okay, and I worked out x minus 6 to be 14, then I get 5. Okay, and does 3.5 plus 5 equal 8.5? Yes, it does, so you know you're right. Okay, and so then you write yourself a sentence. The average speed from the pass to Flin Flon is 20 miles per hour. Okay, and you're done.